Previously, we discussed at a really high level what are the most important concepts of the regression analysis. We look at what are the dependent variables, the independent variables. Today, I want to show you one example, one visual example, where we are going to go through a business problem in which you will have the dependent variables, the independent variables, and we are trying to find the best way to predict what the dependent variable is. Let's take a look at it. In this example, we are going to try to figure out what is the relationship between the time after a campaign by a competitor started and how our sales increase over time. To do this, we are going to draw a graphic in which on the x-axis, so this is the horizontal axis, we have the time. So this is time, and we are going to measure this time in days. And then in the vertical axis, we are going to have sales, and this is going to be in dollars. And what we are observing is at the beginning of the competitor's campaign, this is the day 0, how much sales we got. So we began somewhere here. So we have a point here. So this is how many sales we had. And say we have, 1,000, 1,500, 2,000, 1,500, 3,000, 1,500, 4,000. You get the idea. And at the first day of the campaign, we start here, and then we keep adding days. So this is the first day, this is the second day, third day, fourth day, fifth day, and so on. Say we go a full month after the campaign of our competitor started. And at the beginning, as you can see, we land somewhere between 2,000 and 2,500. Then on day 2, we are a little bit lower. Day 2 here, day 3 somewhere here, 4 number here, 5 somewhere here. And so it keeps growing, and at the end, we end up somewhere here, right? So these are the data that we have. And as you can see, there seems to be indeed a positive correlation. By correlation, I mean a positive relationship, how time increases and sales also increases. And what we can do is that we can plot a line, and this is just something that we do with our hands. So we are not using any mathematical device for this yet. We have a line, and this line sort of like gives us an intuition of what is the relationship between these two variables. And again, to recall what we were talking about, sales in this case is going to be the dependent variable because it depends on time after the campaign. So time is going to be the independent variable, right? So this is what we defined in the last video. So what the dependent variable is, now we know this is going to be the sales after the campaign of the competitor. And time, well, that is the independent variable. This is what we actually measure, and we want to predict what is going to be the sales after a given amount of time. So how do we find what that relationship is, right? So how do we calculate that line? Well, what we are searching for, and I'm not going to in the mathematical details of how you do this, but what you're searching for is for a line like this one, where when you calculate the distances, let me move this a little bit. When you calculate the distance between the sales that you had and the line, See, so here we have a collection of distances, and this is the distance number 1, this is the distance number 2, distance number 3, distance number 4, distance number 5, and so on. So you have a collection of distances, distance 1, 2, 3, and so on, right? Until you get to the date 30. What you want to find is what is the line that minimizes a kind of sum of all these distances. So what you want is a line that is at the minimal distance between all the points that you have gathered through your data gathering process. And this line that you find here is going to be the model that best describes the relationship between sales and time. Now, in this particular case, because we are drawing a line, we are going to say that that relationship is going to be a line, right? So we say that sales is going to be the initial sales that we had at the first day. So this is this point here. We put this little 0 down there to indicate that it's the initial sales. So it's going to be sales initial plus some number. We're going to call it M multiplied by the time, which is how many days have passed. And the objective of calculating to finding the line that has the minimal distance to all these points is to find who this number M is. And when we run the algorithm that finds what the number M is, then we have solved our regression problem. And that's essentially it. You could do it more complex. So if you know that the relationship is not linear, meaning it's not a straight line, but is some sort of curve, because you can see it with your eyes, that it's going to be some sort of curve, then you might propose a different relationship here. So instead of proposing this linear relationship, and instead of proposing this, you might propose some other line that minimizes these distances across all the points of the data that you gather. And that's essentially how you do regression. Linear regression is oftentimes the go-to method for many organizations. It's very simple to implement. Many times you just need to know what is the growth of rate or the direction of rate or of certain magnitude. And for this reason, it's widely used. You can also find it in many tools like Microsoft Excel, which is super straightforward to run this analysis automatically. So you just need to put the data there and just run the regression analysis, and then you get all the coefficients and all these distances calculated for you. In a future video, we are going to look at what are the things you have to look after not to make significant mistakes when you're running regression analysis.